This facility represents a next-generation smart factory designed exclusively for high-density fiberboard manufacturing.
How do raw wood chips transform into high-density fiberboard through a fully automated smart factory?
How can data, automation, and precision control turn wood fibers into high-performance HDF boards?
Digital systems monitor HDF board density, thickness targets, and press temperatures in real time.
This fully automated environment minimizes human intervention while maximizing HDF production consistency.
Raw wood chips are delivered automatically and prepared specifically for HDF fiber processing.
Conveyors transport wood chips forward toward dedicated silos for controlled HDF raw material storage. Inline sensors measure wood chip moisture to ensure stable conditions for HDF fiber quality.
Vision inspection systems remove foreign materials that could affect HDF board performance. Rejected materials are diverted instantly, while approved HDF raw material continues forward.
Only uniform, clean wood chips are allowed to enter the HDF processing line.
Each batch is digitally tracked to ensure full traceability of every HDF board produced. Prepared wood chips now move directly into the size-controlled chipping process. Wood is reduced into controlled chip sizes suitable for high-density fiberboard production.
Precise cutting ensures chip geometry optimized for consistent HDF fiber separation.
Uniform wood chips exit the chipper and proceed toward the screening system.
Screening separates acceptable chips for HDF fiber refining from oversized or fine particles. Dust and fines are removed to protect downstream HDF processing equipment. P20 approved chips advance steadily toward HDF fiber refining.
Steam pretreatment softens wood chips in preparation for HDF fiber defibration. Controlled steam release initiates the transformation from wood chips to HDF fibers. Refiners mechanically separate wood into fine fibers suitable for high-density boards. HDF fibers are conveyed pneumatically toward the resin blending system. Process parameters are continuously adjusted to stabilize HDF fiber quality.
Uniform HDF fibers form the structural foundation of every finished board. Fiber transport remains fully aligned with the main HDF production direction.
Prepared HDF fibers now enter the adhesive application stage.
Adhesives are dosed automatically to meet high-density fiberboard bonding requirements.
Resin ratios adapt dynamically based on HDF fiber moisture and board specifications. Consistent resin coverage ensures structural integrity of the final HDF board. Resin-coated HDF fibers enter the drying system for moisture stabilization.
Hot airflow removes excess moisture without damaging HDF fiber structure. P35 inline sensors verify dryness before HDF forming. VO sensors verify correct fiber dryness before HDF mat formation.
Conditioned HDF fibers advance toward the forming line. HDF fibers are evenly distributed onto the moving forming belt. A uniform HDF fiber mat is created with controlled thickness across the full width.
Laser scanners continuously measure HDF mat thickness in real time.
Automatic corrections maintain consistent mat density and geometry.
The HDF fiber mat enters the continuous hot press. Heat and pressure compress the mat into a dense HDF board structure.
Internal density increases progressively as fibers bond under pressure. Adhesives cure, forming a solid HDF board core.
Finished HDF boards exit the press with controlled temperature release.
Boards are transferred automatically to the cooling section. Cooling conveyors stabilize HDF board dimensions and internal stress.
Thermal sensors monitor HDF surface temperature continuously.
Conveyor speed adjusts automatically to maintain board stability. Edges of HDF boards are trimmed to precise industrial dimensions. Both surfaces of the HDF board are sanded for flatness and smoothness.
The finished HDF surface shows high density and uniform texture.
Non-conforming HDF boards are removed automatically from the line.
Decorative layers are aligned accurately onto the HDF board surface. Heat and pressure bond the surface layer to the HDF core.
Protective coatings are cured to enhance HDF surface durability.
E58 automated testing measures HDF board density and strength. Mechanical testing verifies HDF board strength and density compliance.
Emission tests confirm HDF boards meet E0 or E1 standards.
Each HDF board receives a traceable identification code.
Finished HDF boards are stacked and palletized automatically.
The smart factory operates continuously with synchronized HDF production systems.
High-density fiberboard is manufactured with precision, automation, and industrial intelligence.